Okay, now today is the last session in week number 6 and in matrices. Today we are going to close this topic, and what is left is the third topic to be discussed this semester, which is the differential equation. Next session, inshallah, not next week, the week after, we will start with differential equation. But today, just introduction to differential equation using matrices. Okay. Now, first of all, let me clarify what is differential equation. Now, we will talk about it in more details, inshallah, at that time. But here, just to let you know that, when we differentiate y with respect to x, when we differentiate, let's say as example, it will be x, the result. Okay. Now, this is a differential equation. Okay, because here we have the differentiation of the subject, which is y. It means y dash equal x. It's the same one here. Now, when we solve differential, what we want to do, we want to step back. We're returning back to y. It means convert this from dy over dx into y. So I have differentiation. I need to integrate it to back to the original state. Rather than I have dy over dx, I will have y. Rather than I have y dash, I will have y, right? So, now if you look to this set of equations, okay, equation 1, 2, blah, 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 you can see here the variable is x1 dash. By the way, it's not necessary to be dy. It could be any name, okay? So x dash equal a11 x1, a12 x2, and so on. x2 dash, oh, what this tell me? This tell me that my variable here, okay, the function here is dx1 over dt with respect to t usually. a11 x1 of t, a12 x2 of t, and so on. And here it is dx2 over dt, and so on. dx1 over dt. I want to solve them, but I will not solve them similar to the methods to be discussed later. No. Now I will solve them using matrices. Since we are discussing matrices, I will solve them using matrices. I will use eigenvalue, eigenvector. Okay. Now, first of all, we need to write the set of equations similar to what we did in linear equations. We wrote them in a matrix form. In this way, we say that it is x equal a, b, if you remember. And we solve them by elimination, by Gaussian, Jordan, by inversion method, and so on. Now, the same thing we need to do here. We need to write them in a matrix form. This is the set of matrix, okay? And these are their initial condition. It told me that x1 at 0 time equals c1, x2 at 0 time equals c2, and so on. To write it, I will write first the matrix A. I think now everybody know how to write matrix A, right? Second, I will write the variable x. As you can see here, it's a column x1, x2 until the end. And I will write the x dash, x1 dash, x2 dash, and so on. So this is the general form. I convert my set of equation into x dash equal a x, okay? Let me explain the theorem, how we will solve it, and then with example, it will be very easy. Now we will come to assume that, okay, x is this function, qy, okay, where q is invertible function, have inverse. And if I differentiate this equation, it will become x dash equal q y dash. Okay. Now, if I take this part and substitute it here, I am approaching here. If I multiply both sides of equation by y dash, by q dash, q inverse, So this one would cancel with this one. What is left? Y dash equal to this part times y. Have a look at this part. Supposed to remind you with something. Yeah, We discussed this last session when we have, if you remember, P inverse AP, okay? It gives me the matrix with a diagonal, with this diagonal contain the eigenvalues. So it make my task easy, because if I got y, if I solve this and get y, I multiply by q, I got x. Very simple. Let's apply it here in this example. Have a look. This example is x1 dash equal x1 plus 3x2. x2 dash equal 2x1 plus 2x2. Now when to write the matrix A, I will say 1, 3, 1, 3, 2, 2, 2, 2. Now I got matrix A. Matrix X, this one, you see x1 and x2, it's available in both equations, x1 and x2. To write the matrix x dash, x1 dash, x2 dash, I got it here. Also, he told me that x1 at time 0 is 0, x2 at time 0 is 5. So I will say constant C equals 0 and 5. Now this is the general form of the matrix after I convert it into, the equation after I convert it into matrix form. X dash equal A, X, and this is the constant. I solve A. I got eigenvalues. We know how to solve to find eigenvalue. We started in this way, A minus lambda I equals 0. I go through the solution until I get lambda. From lambda, I get P, which is the eigenvector for each eigenvalue. So I solved the previous equation, this one, A. I got eigenvalue and eigenvectors. Eigenvalues are 4 and minus 1. For each one of them, there is eigenvector. This is 1 and this is 2. Now I build my matrix Q, which represent the first eigenvalue, the second, first eigenvector, the second eigenvector. So Q here, let me back to the theorem. Q here, which is important to find the Q. Q here is this matrix. Matrix constructed by eigenvectors. Okay. Since I got it, everything will be fine. Now this Q, if I multiply Q inverse, I find its inverse. I multiply it by A and then by Q, I got D, which represent matrix, diagonal matrix. Its diagonal is eigenvalues, the one I just got. You see? I got it. Now I can substitute. To find the value. Have a look. X1, X2 equal Q, Y. We say X, here we are. X equal QY. Q, I already got it here. The eigenvectors. I put it here. Times Y. Now X1 equal 1 times Y1 plus 3 times Y2. The same thing, x2 equal 1 times x1, y1 plus minus 2 times x2. I'm here. Now I need to find y. Next, to find y, then if I find y, it means I got x1 and x2, which is what I'm looking for. Because you remember where we started? We started here. X dash equal ax. If I solve it, it means I find x. Now this is what I'm looking for, to find x. What is left is just finding y. And we say that y dash equal dy. Okay. Now y dash is y1 dash, y2 dash, and y is y1, y2. What about d? Let me back. I told you here. D is the diagonal matrix, and the diagonal elements represent the eigenvalues, as you can see here. Now it's easy to find solution for this one here, because y1 dash equal 4 y1, 0 is not there. y2 dash equal minus 1 y2, we are here. And this can be written simply dy1 over dt equal 4 y1. And this one dy2 over dt equal minus y2. This one, the first one, I can solve it easily because dy1 over y1, I will take it down, equal 4 dt. If I integrate, this will give me ln y1 equal 4t. And if I take exponential here and here, y1 will be exponential 4t. This is the solution. I got y1, just let me back here. Let me back here. I substitute here. I got y2, I substitute, then I got the results. You got it? I will summarize at the end. You see? I solve for y1, y2. I will back to substitute here. y1, y2. You see here? y1, y2. The one I just got it. Then I will multiply this row by this column. It gives me the first equation. This row by this column, the second equation. This is the solution of my set of differential equations. What is left is the constant. How we find the constants, these C1 and C2? It's very simple because he gave me in the question, if you remember, initial condition. Where is it? Yeah, here we are. He told me x1 at time 0 equals 0, x1, x2 at time 0 equal 5. So I will use this. I will substitute for time by 0, as you can see here, everywhere by 0. And the x1 at 0 is 0, x1 to 0 is 5. And solve these set of equations simultaneously. Set of simple equations simultaneously. Then I got C1 and C2 and back to substitute here. Let me summarize. You are given set of equations. As example, here in my example, I have set of equations. If you can see here, I converted into matrices form. X dash equal A, X. I take A. I try to find its eigenvalue. We solved many problems for eigenvalues. Let me say I got lambda 1 and lambda 2. For each lambda, I will solve to find the eigenvector P1 and P2. Now here, I have two matrices to be constructed. The first matrix is a Q matrix, which represent P1, P2. These vectors, eigenvectors. And the second matrix is D, which represent lambda 1, lambda 2, 0, 0. I need these matrices to solve the problem. I go through the procedure here. As you can see, I constructed them. I know that X will be Q, Y, and I have a Q already. This is a Q. I got equation with respect to Y. Then I need to find Y. It's like a substitution function of function. Okay? Then I want Y. To find Y, I need to solve Y dash equal dy. I have dy. I solve it, and then I back here to solve it to find x1 and x2. Now, this set of two equations, if I change the number, the procedure will change? No, the same procedure. Whatever the numbers I give here, as example for my matrix A, you see matrix A, I got it 1, 3, 2, 2. Whatever the numbers, change the numbers at the end, you have the same procedure. Okay, you may ask a question, okay, what if I have a 3 by 3, similar to the assignment we have? Very simple. Rather than 2 by 2, 3 by 3. 1, 2, 3, 4, 5, 6, 9 elements. 8, 7, 9 elements is the end. What if it is 4 equations, 16 elements, and so on? You got it? It doesn't matter, the procedure will not change. You put this example in front of you and you follow the procedure. Number will change. Numbers will change, but the procedure never change. Okay? It's the same procedure. Now, up to this point, I completed the second topic. Let me just remind you what we discussed in the 6 weeks, the first 6 weeks. We are in the middle of the semester. We have two topics covered in the first 6 weeks. These are the vector calculus, where we went through vector, we revised vector, its operation, product, cross product, dot product, and then we want to do gradient, dual, normal value. Then we went through the directional derivative of vector in the direction of scalar in the direction of vector. We discussed the line integral, scalar 1, vector 1, Green theorem. After that, we went through the matrices. In matrices, we started from the principles, the idea behind matrices. We went through the classification of matrices, square matrix, diagonal matrix, scalar matrix, symmetric matrix, skew matrix, upper triangular, lower triangular, and identity matrix, row echelon form, reduced row echelon form. Then we discussed the operation, addition, subtraction, multiplication of matrices. And then determinant, we define determinant. We solve determinant using cross product, cofactor expansion, row reduction method, 3 methods. Inversion also, inversion of matrices has been discussed, adjoint of matrices. And then when we finish all the bases to start solving set of equations, we solve the first set of linear equations. We solve it by elimination, we solve it by Gaussian Jordan, we solve it by inversion method. And then we move to the eigenvalue and eigenvector. We started from the characteristic equation, we solve it to find the eigenvalue, and then for each eigenvalue, we found eigenvector. And today, we use all of these discussion in matrices to solve set of differential equation. One example, but more than enough. You will also practice more in tutorial, but this example is more than enough because it's the same procedure. Numbers will change, but the procedure is the same. Now I will stop for this part here.